In this video, we'll be going over some root to leaf numbers. So you're given the root of a binary tree containing digits from 0 to 9 only. Each root to leaf path in the tree represents a number. For example, the root to leaf path 1, 2, 3 represents the number 123. Return the total sum of all root to leaf numbers. A leaf node is a node with no children. So in our first example, we're given this tree, and then the first path we get 1 and 2, so it represents 12. And then the other tree is, or the other path is 1 and 3, so it's 13. So 12 plus 13, we get 25. Let's go over the thought process. We will be implementing a recursive approach. We will keep track of the current sum, or the current path, in our recursive parameters, or current path number in our recursive parameters. Then for each of the node x, we will first multiply num, or we can denote this as num by 10 before adding x.val. So for example, if we're currently at this number, and then initially our path number is equal to 1. We want to multiply 1 by 10 first, so we get 10, and then we add the current number, so we get 12. If x is a leaf node, then we have found a path number. We can just return num. If x is not a leaf node, we will want to continue to find the path number on its left and right subtree. Let's go over the pseudocode. So we're going to implement the recursive approach, and then what parameters do we need? We first need node, the current node that we are visiting. And then we have the number, the current path number, initially 0. And then we do not have a base case. Actually, we do have a base case. Where's the base case? If node is equal to node, then we have this node path sum here, so we can just return 0. Because we only want the path number from root to leaf. Then each of the recursive call, we're going to multiply num by 10 and increment. Then we're going to increment num by node.val. Now if both child or both children node of node is equal to null, that means we have reached a leaf node, so we can just return num. This is the sum of, this is the current path number. Else, we will first recursively find the path number on the left subtree. We'll just node to node.left, and then num gets updated. We pass in the updated number, and then recursively find the path number on the right subtree. Num also gets updated. Then we want to return the sum of the two leaf paths. Now let's go over the time and space complexity. So the time complexity is O of n, where n is the number of nodes in the input tree. O of n is visit each node once. And our space complexity is O of n, or O of h, where h is the height of the tree. This is the recursive call stack memory. Let's go over the code. We're going to implement our recursive approach, roots, and the current path number. The base case, if node is equal to null, we have failed to find a path, we can just return 0. Then we want to increment, we want to multiply a number by 10 first before adding the current node value. And then we check if the current node is a leaf node or not. If both of the children nodes are null, we have found a leaf node. We can just return number. Else we want to return the sum of the number on the left path and also the sum of the number on the right path. Let me know if any questions in the comment section below.